Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Hafizam bin Hamzah. My matric number is 045886. My group's name is Bazli. Okay. My title is Distribute Operating System. Okay. Today I want to tell you about Distribute Operating System structure. Distributed operating system is a model where distributed applications are running on multiple computers linked by communications. The distributed operating system is an extension of the network operating system that supports higher levels of communication and integration of the machines on the network. The system looks to its users like an ordinary centralized operating system but runs on multiple independent central processing units (CPUs). These systems are referred as loosely coupled systems, where each processor has its own local memory and processors communicate with one another through various communication lines, such as high-speed bus or telephone lines. By loosely coupled system, we mean that such computers possess no hardware connection at the CPU memory bus level, but are connected by external interface that run under the control of software. Okay, you can see the structure beside me, behind me. Okay, I think that's all for today. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syukri bin Abdullah. My matric number is 045070. I am from Diploma Teknologi Maklumat Multimedia. Okay, today I want to present about distributed operating system. Okay, my title is scheduling in distributed operating system. Firstly, I want to talk about definition. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Process scheduling is an essential part of a multi-programming operating system. In general, scheduling refers to assigning a resource and a start time and to a task. Much of scheduling research have been done in operation research community. Okay, next I want to talk about criteria of scheduling. I there have 5 criteria: CPU utilization, throughput, wait time, response time, and turnaround time. Description of CPU utilization: reduce the strain on the CPU and manage the percentage of time the CPU is busy. Criteria of throughput: description is increase the number of processes complete in a given time frame. Wait time description is reduce the waiting time of a process. Next, response time is minimize the time a user have to wait for a process to run. Lastly, the runtime. The runtime is total time a process takes to run from start to finish. Next, I want to tell you about graph scheduling algorithm. Graph scheduling algorithm include by guided random search space. There have 1, 2, 3, 4 heuristic space. Heuristic space have list scheduling level by level, clustering priorities, and task application. Okay. For the conclusion. My conclusion is hierarchies for scheduling independence and dependent tasks on distributed system. Second, rescheduling in order to adapt to dynamic grid condition. And third, partitioning in case of tough graph. Lastly, the future lecture at November 27 on research provisioning for application. Okay, I think that's all from me. Thank you.
Hello, Assalamualaikum. My name is Mohammad Hadri bin Hasanuddin. My metric number is 045927. So today I will talk about process synchronization. Process synchronization means sharing system resources by process in such a way that concurrent access to share data is handled, thereby minimizing the chance of inconsistent data. Maintaining data consistency demands mechanism to ensure synchronized execution of operating processes. Process synchronization was introduced to handle problems that arose while multiple process executions. Some of the problem is a critical section problem. So, critical section problem is a code segment that access shared variables and has to be executed as an atomic action. It means that in a group of operating processes, at a given point of time, only one process must be executing its critical section. If any other process also wants to execute its critical section, it must wait until the first one finish. So for example, the first section is entry section. Entry section controls the entry into critical section and gets a lock on required resources. And the critical part is the critical section, and the second section is exit section. Exit section remove the lock from the resources and let the others know that its critical section is over. And the rest of the section is remainder section. So the solution to critical section problem is the solution to critical section problem is mutual exclusion, progress, and bounded waiting. The first one is mutual exclusion. Mutual exclusion is out of a group cooperating processes. Only one process can be its critical section at a given point of time. And the second condition is progress. Progress, if no process is in its critical section, and if one or more threads want to execute their critical section, then any one of these threads must be allowed to get into its critical section. And the last condition is bounded waiting. After a process makes a request for getting into its critical section, there is a limit for how many other processes can get into their critical section before this process request is granted. So after the limit is reached, system must grant the process permission to get into its critical section. So we move to the synchronization hardware. Many systems provide hardware support for critical section code. The critical section problem could be solved easily in single processor environment if we could disallow interrupt to occur while a shared variable or resource is being modified. In this manner, we could be sure that the current sequence of instruction would be allowed to execute in order without preemption. Fortunately, this solution is not feasible in multiprocessor environment. Disabling interrupt on a multiprocessor environment can be time consuming as the message is passed to all the processes. This message transmission lag delays entry of threads into critical section and the system efficiency decreases. In the last one, we move to the mute box. As the synchronization hardware solution is not easy to implement for everyone, a strict software approach called mute blocks was introduced. In this approach, in the entry section of code, a lock is acquired over the critical resources, modified and used inside critical section, and in the exit section that lock is released. As the resource is locked while a process executes, its critical section, hence no other process can access it. So I think that's all for me. Thank you.
Assalamualaikum. My name is Amir Bazli Abdul Razak. My metric number is 045496. Okay, so today I would like to talk about deadlocks in distributed operating system. First of all, we know that in deadlock we got mutual exclusion, who and with, no preemption and secular with in deadlocks. So I'd like to explain a little bit about this thing that I said. First, mutual exclusion. It means resource can be held by at most one process. Second one, hold and wait. We can processes that already hold resources can wait for another resource. Third one, non-preemption resource. Once granted, cannot be taken away. And the last one, circular wait. Two or more processes are waiting for resources held by one of the other processes. So the second point about dialogue is dialogues can be modeled using resource allocation graph. And the third one is handling deadlock. We got 3 points in handling deadlocks. So the first one, avoidance. Avoidance is requires advanced knowledge of processes and their resource requirements. And the second one, prevention. Prevention is collective or order request and prevention. And the third one is detection and recovery. For example, it means local or global WFGs, local or centralized deadlock detectors, and recovery by operator intervention, termination and rollback. I think that's all for me. Thank you.
Okay, we come back again. Next, I want to talk about files and directories structure. Okay, files have several common characteristics within. Each file is made up of data, but also metadata is embedded into the file to help the operating system manage how the file works and how it is stored. Metadata records file information such as the author, file creation date, modified date, and file size. Okay, next is directories. Files are not just randomly scattered on a form of storage media. There is what is called a directory. Think of a directory as an invented root system. It starts at the top with a single entity of a computer hard drive. On a PC, the primary drive is called C, where the indicates the drive letter assigned or member. On a Linux system, the drive prompt is a $sign. In both these cases, this is called the root of the drive. From here, we think of a directory system as a series of branches or folders containing collections of similar files. For example, on the Microsoft Windows OS, the Windows directory contains the vast majority of files necessary for the OS to work and administer files and processes. Okay, you can see the diagram beside me. Okay, I think that's all. Thank you.